Hey everyone, today we are starting a new unit on graphs of all of our different trig functions. So we're basically I don't want to say starting all over, but we're looking at our trig functions in a totally different way because now we're going to be graphing them and doing different things with those graphs. So today we're going to talk about the most basic form of the sine graph and the cosine graph. So this is right off of your note sheet, so make sure you are following along and you're writing stuff down on your note sheet so that you have it to refer back to. But we're going to start with the graph of sine. And before we go into doing the graph, let's talk about a couple of things. If you notice here, I have our angle measures in degrees and in radians, but you'll see on the graph itself, these are in terms of radians. And the reason for that is, and we'll always be doing our graphs in radians, and that's because it translates well into numerical values, right? So we're basically keeping our units the same instead of having degrees on one side and just regular units on the y-axis. We're keeping everything in units. It's just our the breakdown of our units is different as opposed to having completely different units. Okay, so that's the first thing. We're always going to graph in radians, so our x-axis will always be in radians, not in degrees. So that's why it's really important to understand those radian measures, where they come from, what they mean, and all of that. You'll also notice that I'm doing all multiples of 30 up here, and that's because when we graph, right, those are our special right triangles, or 30, 60, 90 triangle, and it just lends itself to really showing you how that graph is laid out, what it looks like, and it helps to sketch it out. So that's the idea behind that. Okay, so let's go ahead. I also want to mention that you'll see here we've got our quadrantal angles as well, so that's important. So not only do we need our special right triangle, our 30, 60, 90 triangle, and if this is 30, that'd be 1, 2, and root 3. I also need my unit circle, because remember, with your unit circle, you've got x and y coordinates, and the y coordinate is always the sine of the angle. So this is -1, 0, and this is 0, -1. Okay, so we're looking at those y coordinates. So let's go ahead and fill in this table, and then we'll talk a little bit about the graph and some of the characteristics of the graph. Okay, so the sine of 0. So I'm going to just fill in my quadrantal values first. Okay, the sine of 0 is 0 because it's the y coordinate of that point. The sine of pi over 2 is going to be 1. The sine of pi is going to be 0. The sine of 3 pi over 2 is going to be -1. And then the sine of 2 pi is going to be 0. Okay, so we have those values. So if I were to plot those points, I'd have 0, and then at pi over 2 I'm at 1, then at pi I'm at 0, and then at 3 pi over 2 I'm at -1, and then I'm back here at 0. Okay, so I have those values. Sine of 30 degrees is 1/2, so that's 0.5. And the only reason I'm putting decimals here is because it's just easier to graph with a decimal than to graph like 3 pi over 2, right? So 3 pi over 2, if you were to convert it to a decimal, that would be 0.87. And then 120, remember, is in the second quadrant, so your reference angle is 60, so it's going to follow 60 degrees. Sine is positive in the second quadrant. Okay, and then would be back here at 0.5 because 150 degrees has a reference angle of 30 degrees. So all of the stuff we did in the last unit is translating over into this, but we're just looking at our trig functions a different way. But all of those things you learned are still applicable here. Let's go on to 210 degrees. That puts us in the third quadrant. Sine is negative in the third quadrant. Okay, so if you're thinking about this, remember sine is negative in the third quadrant. 210 degrees would give me a reference angle of 30. Remember, you're always going your distance from the x-axis. So that's going to be negative 0.5. And hopefully you're seeing a pattern here. At 240, I'd be at negative 0.87 because my reference angle would be 60. And then when I get down to 300 degrees, I'm in the fourth quadrant. Sine is negative in the fourth quadrant. My reference angle here is 60 degrees. And then my reference angle here is 30 degrees. Okay, so that's what my chart looks like filled out. So I can go ahead and plot those points. So I would be at 0.5, and then I'm up here somewhere right around here, 0.7 or 0.87, 0.5, and then 0.5, 0.87, 0.87, 0.5. Now, your sine curve and your cosine curve as well, they're continuous functions. They're nice and smooth and curved. They're not straight, jagged lines. Okay, so let's see if I can sketch this on here. So we have a nice curved line, a curved continuous line. Okay, so it should have these nice curves in it. And that's what the sine graph looks like from 0 to 2 pi. It does, you can go in the other direction as well. Like I said, it's a continuous function and is a function that is symmetrical about the y-axis. We'll get into the whole idea of even and odd functions eventually, but let's just talk about the graph first, okay? So I can graph this on this side as well, and it's going to, like I said, it's going to be symmetrical over that y-axis. So what's going to happen is our graph is going to end up doing this. And then it goes up, and then it comes back down, okay? So that's supposed to be a nice smooth curve, kind of. I obviously didn't draw it very well, but you get the idea. It's a nice smooth curve, and it will go on forever and ever and ever, just following this pattern. It oscillates, as we say, right? It goes up to 1 and goes down to -1, and up to 1 and goes down to -1. So let's talk about the properties of this graph. They're listed on the bottom of your note sheet. And you'll see on there it says a couple of interesting things. So for example, we know that the graph tells us where the sign is positive, where it's negative, where it's increasing and decreasing. Okay, it's positive from -2 pi to -pi. It's positive from 0 to pi. Right, it's negative from -pi to 0, or from pi to 2 pi. Okay, so typically you'll see graphs from either 0 to 2 pi or -2 pi to 2 pi. They'll tell you what range they want you to look in. We can tell from the graph where it's increasing and decreasing. Okay, we can also tell the values of the quadrantal angles. Those were the first ones we filled out in the chart. The maximum value of y equals sine x is 1. You'll see it doesn't go any higher than 1, and it doesn't go below -1. Our domain is all real numbers, but this is going to go on and on forever in the negative x direction and the positive x direction. It's continuous, so there's no restrictions on it. The range, however, like I said, it has a maximum of 1 and a minimum of -1, so it will just stay between those two values. So that is going to be your range from -1 to +1. It has translational symmetry of 2 pi, 0. That means it repeats itself every 2 pi, right? So at -2 pi it was at 0, but then it doesn't get back to 0 again until you reach 0. And then the graph doesn't come back, right? It doesn't, the whole cycle itself, and we'll get into the whole idea of cycles and all of that, is 2 pi. Yes, I hit 0 again here, but it doesn't the graph doesn't go up and then go up and then go up, right? It does one whole cycle. It goes up and then down and then comes back to 0 every 2 pi. So that's what it means by translational symmetry. And we'll get into that more as we go. The period is 2 pi or 360 degrees. Period, and we're going to get into this in great detail as well, period is the how long it takes for the graph to complete one cycle. That's what period is. Don't get too caught up in the terminology right now because we're going to get into that extensively as we go, but that's what period is. Amplitude is how high the graph goes, so our amplitude is 1. And it is a function, right? I can draw a vertical line anywhere in my graph, and I only cross the graph once. So it is a function. For every x, there's only one y value. However, it is not 1 to 1. Okay, it is not 1 to 1, meaning for every y, there's only one x. That's not true. Okay, key values when you're sketching your trig graphs, you want maximums, minimums, and zeros. So those are your key values with that. And I just want to show you this one video because I think it's actually really cool. And I'm just going to pull it up here. And it kind of gives you an idea of how the unit circle relates to your graph. Okay, so let me show you what's happening here. You'll see we have this unit circle here, and as you go around the unit circle, so this point A is going around the unit circle, and then E is graphing that value. So you see as you go around the unit circle, all of those values that are on the unit circle are being translated on to this graph. So I'm basically taking this circular function and sort of unfolding it and laying it out flat. So that's essentially what is happening there. Okay, so I just wanted to point that out to you. It's kind of a funky little graph, but you can get the idea of that and how that works. So that's a sine graph. I'm going to stop the video here, and there'll be another video for the cosine graph. All right, thanks everybody.